Okay, I want to remind you in the last, part of this question over here, we're still on question number two, by the way, still question number two. We did the first part, and we were able to get this over here, that the equation of the tangent line at the given point was y equals px minus p cubed. And what was the point there? The point here was going to be 3p squared, comma, 2p cubed. All right, that we found the equation of the tangent line. Now, what they're saying over here, they say find the point of intersection, this parametric curve C, at the point. Well, I did that line over there, but then they got another point, and the point's going to be 3q squared. So there's another one over here, which is 3q squared, remarkably similar, aren't they? And 2q cubed, all right? So do I know the equation of that tangent line? I do. It's y equals qx minus q cubed. And they did say find a point of intersection. So what I want to do is find a point of intersection. How do I do that? Well, let's write this down. So the y's would have to be equal. So that means px, if they're going to intersect, by the way, minus p cubed would be equal to qx minus q cubed. And we're trying to find a point of intersection. By the way, they say something else, and I'll get there later, but I do need to find a point of intersection. I'm trying to parse the language a little bit at a time. So it's going to be px minus qx. We're trying to solve for x, by the way, so I get x on one side. And you get p cubed minus q cubed. Now, but I want to tell you that p is not equal to q, right? Now, how do I know that? There are 2 points, by the way, and those 2 points look remarkably similar, but they're not equal. That means p and q can't be the same number. So let's factor this out. I'm trying to find what the x is. It's going to be p minus q. And over here, it's a difference of perfect cubes. So p minus q, and then you get p squared, let's see, plus pq plus q squared. Now, if p is not equal to q, p minus q is not equal to 0. So I can easily divide both sides by p minus q because it's not 0. And what do you get? You get this over here. All right, now what else do I know? Let's take a look at this now. I guess what I want to figure out what the y is in the problem, right? And the way to do that, I'm thinking about how to do that now. What's the easiest way for me to do it? And I guess what I could do is just plug it in, right? And where would you plug it in? I got neither equation. Let me just try. Let me see how this is working out, though. Let me do it in the first equation, which is p. And what's the x going to be? The x is going to be p squared plus pq plus q squared. And then it's going to be minus p cubed. And let's see if we can do that. I'm kind of looking at that, right? And let me just multiply that out. What do you get? You get p cubed. Let's see, plus p squared q plus pq squared minus p cubed. Well, this worked out pretty nice. So this just cancel off. And we left off with, let's take a look at that. I'm going to factor out the pq, by the way. And what do you get there? You would get p plus q, right? I want to try the other equation too, because I am a little doubtful that maybe I made a mistake somewhere. The other equation is going to be q. And what's the x going to be? P squared plus pq plus q squared. And that's going to be minus q cubed. It looks remarkably similar, doesn't it? Let's just go through it. What do you get? Q p squared plus pq squared plus q cubed minus q cubed. This disappears, and then I'll factor out, let's see what I'll factor out there. I guess I'll factor out pq again, right? And we left off with p, and then you're left off with, let me make sure I'm doing this right, q. Well, I am getting the same thing. So I'm getting a point of intersection over here. I'll write this down for you. P squared plus PQ plus Q squared, comma, that's the X value. And the Y value is PQ, P plus Q, right? So I did find the point of intersection, by the way. But what I want to do is I want to keep reading it. And it says, let me just read that. Find the point of intersection of the tangents of C. I did that. There's the two tangent lines. And then again, hence, show that if these two tangent lines are perpendicular. Well, I got something else to show now. And they say they're perpendicular. And if these two lines are perpendicular, by the way, what does it mean? It means the slope of this guy here times the slope of this guy over here is going to be -1. So if they're perpendicular, what do I know? I know P times Q is equal to -1. All right, so P times Q is -1. So I got to start thinking about this. And if that's the case, what would I write down? Well, I guess I could write down what I'm looking at, and this would be what? P squared plus Q squared, and PQ is -1. So I got this over here. And what do you get over here? You would just get, PQ is -1, so you just get minus P minus Q. Again, I'm a little curious about what they said about this, and they said something. They said that the U, let me write this over here, they said the U is equal to P plus Q, all right? I'm going to look at this and see if I can figure that out now. So they did say that. They said the U is equal to P plus Q. And let me see if I can do that. And so I guess if I look at this, this would just be minus U. Right, that's true, by the way, because minus U would be minus P minus Q. I'm trying to verify what they're saying, by the way. Next thing up, I got to square that U. So U squared would be P squared plus Q squared plus 2PQ. So U squared would equal P squared plus Q squared. Remember, PQ is -1, so it's -2. So what do I get over here? Again, I want to get this thing. And how do I do that? I'd have to add 1 to both sides. What would I get? I would get U squared plus 1 is equal to P squared plus Q squared minus 1. So what does this equal? U squared plus 1. Now, this is what we were supposed to show, and we just did that. And again, with the conditions that were given us. So we have this over here. And let's make sure they did write that down. They did write that down. It's time for us to move on to the next question. Thank you. But I'm going to just pause for a moment.